y'all, we're going to go ahead and get started. So thank you everyone for joining our call today. This is our first webinar, so we're very excited to kick off the series with the 100 of you. So first we're going to have Kurt speaking. He's our marketing director. And then we're going to have Mo. He's our sales manager. And I'm Morgan, Q-PAC's marketing manager. So I'm going to go ahead and turn it over to Kurt.
Hey everybody. So today we're going to talk about why you would upgrade. We're also going to talk about the design side of it for reps and engineers around, and a little bit of how to use QUIPS. And then we'll get into some of the installation and operational benefits. And we'll take questions at the end. But also, if you have any questions throughout, please don't hesitate to go ahead and pop them in the comment box. Morgan will be monitoring that the whole time, and we'll answer them as we go. So starting off, commercial building owners and facility managers are spending an extra $60 billion in energy in the U.S. by continuing to operate outdated and inefficient HVAC equipment. So what is stopping them from going ahead and pulling the trigger and updating these systems? Well, it's expensive, time-consuming, and just difficult to upgrade these systems that are so deeply embedded into the building. It can seem easier, more cost-effective just to continue to maintain and repair older systems just to get more life out of them. Just continue to do the work, keep buying and replacing belts, greasing bearings, cleaning blades, and hope that your fans will last another decade, but all while burning more and more energy and wasting your maintenance team's valuable time year after year. Facilities managers' jobs, right, are to ensure their occupants are comfortable and that their building is healthy with clean and fresh air. Because whenever your fan breaks down for even just a couple of hours, you're always going to have that difficult tenant there on the 13th floor that's going to start calling you and letting you know that there's a little too warm. Let me know if I feel like it's pretty common, but if you've had this situation occur, let me know in the comments, raise your hand or send an emoji. You ever had somebody, a facility manager, a mechanical contractor, and they're in a panic and like, shit, this just broke down. I need the solution right now. I feel like that's a pretty common thing. Anybody ever have that happen to them?
All right. This group's the lucky ones. They haven't had that happen to them.
Yeah, totally. So I think the ideal solution, right, is what would actually make it worth it to change your system. I think you need a clear ROI, right? I've seen some cases where the ROI has been as little as 2 years, 4 years is pretty great. That ROI comes in the form of saving energy cost, eliminating maintenance. And let's face it, maintenance budgets are not getting any bigger right now, and they probably won't over the next couple of years. So, facility managers and building owners need to find those better solutions. As far as disruption to the building, the complete installation time should take less than a day. You don't need to shut down any streets. You don't want to have to get any cranes in to bring in equipment, cut a hole in the side of the building. You don't have to knock down any walls inside of the building or use any rigs to handle heavy equipment. And you want to make sure your tenants are happy. So the ideal situation would be doing it over the weekend or overnight when they won't even know anything happened at all. You also want a reliable startup. You don't have to buy or cut out your old system and replace it with something that doesn't work. You need it to work the first time and every time, and you need it to have inherent redundancies. You also want it to be future-proof, right? You don't have to go through this every couple of years. You need it to maintain its efficiency over time, and you want it to last as long as your air handler. So that brings me to the FS1 option. We will ensure you get a clear ROI. Reach out to any of our sales engineers. They will literally do the math for you. They do it every single day, and they're very good at it. There's a lot of things you probably wouldn't consider, and they'll give you a nice spreadsheet with all of that built out. Your savings will come with energy. You no longer have to buy belts or grease, and your maintenance team will save a lot of time. There's always something to be fixed in a building, and they can work on other things. As far as building disruption, you can literally hand carry every single one of our components through a standard door into any service elevator. The hardest part is cutting out the old fan system into pieces and scrapping it. It's typically also what takes the longest. After your old system's out of the way, our kit, you can install our kit and have it installed. And I've literally seen less than 2 hour installations. Obviously, that depends on the size. I oversaw a job in Boston several years ago with our older product. Our new one's quite a bit more efficient. They replaced two 90 horsepower motors, driving two massive DWDI fans, and they installed 44 Q-PAC fans, and they did it over the weekend. Their tenants never even knew anything happened. It's also super reliable. If you get an N+1 configuration, even if you lose a fan, you will still maintain the designed operating set point. And look, it's plug and play. We have our patented Quick Connect box. Our system comes with harnesses that you snap onto the bulkhead wall, so you just can't get it wrong. You do have to connect power and an 8-conductor control cable between the Quick Connect box and our control panel, and that's it. If your BMS goes down, or you have power issues, we've got everything backed up with fuses. If your BMS goes down, you walk up to it, you put it in hand mode, and it bypasses your BMS and our controller and everything, and it'll run until you get your control side fixed. Our system's designed to outlive your air handler. It's actually common for customers to buy our system and then plan to reinstall it in a new air handler after a few years. So I actually had a facility manager reach out to us, and he said, "Man, I really wish I knew about your product sooner," because he had just paid for 16 weeks of temporary air to make sure his tenants were happy, right? Because that's how long it took for him to get a custom-made, brand new fabricated shaft to drive this 40-year-old DWDI fan. And it actually would have cost him less if he just would have went with Q-PAC from the very beginning and did our 48-hour quick ship option. And he even stated, he's going to end up buying us and replacing it anyways with Q-PAC. So to the design side and QUIPS. So this is for reps and engineers out there. We built this tool to make your life as simple and easy as possible. All you have to do is enter a few data points with the dimensions and the operating point, and you get custom drawings and specs and a quote in literally 5 minutes or less. We do all the work for you, which means you can spend more time really doing what you do best and building your relationships with your customers. I know some of you already use this tool, but there are a lot of you that don't, so I'm just going to give you a really quick tour. So if you don't have an account, reach out to our account managers. They'll get you set up and going right away. Once you have your account, go to quips.io. Once you log in, you'll see this screen. It will show you all of your historical jobs, and whenever you want to start a new project, just click Create Job. You'll be met with this pop-up screen. Just type in the project name, the vertical market that you're in, and the installation type that you're doing, and hit Submit. Create products. So I'm going to add a couple products, and then you'll get this screen where you can add the tag of the air handler and the airflow, the static pressure, the dimensions, the power, and we have a few options you can choose from, like dampers, premium and basic control options, and a few other things. So in this example, we've got a return fan and a supply fan. You'll be brought to this screen. So this is the supply fan. If you want to change any of your parameters, you can change them over to the left and hit the update button. You can sort by efficiency. You can sort by redundancy, number of fans, and several other things, horsepower. Once you find the selection that's best for you, click Select next to the one you like. It'll bring you to this screen, and you can scroll down once you're in here and look at all the specs and all the data, the sound data as well. It's all there, electrical. You can even download some drawings and PDFs. Then once you select your units, you create a quote, and then you hit that Submit button. Once you hit that Submit button, you will receive an email confirmation that says, "Hey, we will be shipping it in 4 weeks." It's that easy. So from here, I'm going to hand it off to Mo. He's got some great examples, jobs that he's going to go through with you guys.
Thank you, Kurt. I don't know if there are any questions right now. I don't see any questions, but if there are any, please type in You can see that chat box over there on the right side, so you can type in there. And at any time, Morgan, please let us know if there are any questions. I can hand it over to Kurt to answer. Good afternoon, everyone, or if you're in the West Coast, good morning. I'm sure a lot of you miss webinars. I do every day, and that's why we decided to do a webinar. When we decided to do this, I just went through Kurt's idea to see what he wanted to do, and based on what he went through, I went through my emails just to find an upgrade, a job that included a lot of those reasons why people go and upgrade their fan systems. And I picked one that was really fun for me to do. This was, well, first of all, we were involved since the beginning, all of the engineering, and and this was, for me at least, an interesting location. This is the northernmost project that we've ever done, pretty close to the Arctic Circle in Northwest Territories. An iconic building in Yellowknife, and the building was built in the 60s and is the government building of the Northwest Territories. They went through an upgrade of their air handling units. So the AHUs were upgraded in 2001. The AHUs and the fans were still operational, but they were getting close to the time that, they were already maintaining these fans. They were already spending a lot of money. And this is a remote location. So maintenance actually shows, the amount of money that they're spending on these fans was showing. And they just didn't want to spend that money every year on maintaining these fans. Let's go through the existing fans that they had. So they didn't have any redundancy. They had one fan for supply and one fan for return. And as you see, it was delivering air to the whole building. It was a 73,000 CFM on the supply side and around 70,000 CFM on the return side. So they were relying on one fan for all of their cooling and heating of that building. And their main reason to upgrade was, first, they did not want to go through a catastrophic failure of the fans, because it would have been a disaster in the cold in winter if one of the fans failed. It's a remote location, so it would have taken a long time to just transfer and ship these fans to the location. And winters are very difficult for maintenance, for replacing the fans. They were going to upgrade their energy recovery runaround coils as well. So they were going to add a little bit of static to their coils and to their system. And that was another reason to upgrade the fans. The fans couldn't go really; they were pretty close to their high static, so they didn't want to use these fans. And as I said, the maintenance requirements were going up. There was a high risk of failure in a remote location, and they had no redundancy. So that was the main reason to just avoid a failure of these fans. The challenge for them, firstly, it's a remote location. It's a challenge to do anything in that part of the world. But also they had a problem with space, and they had a problem with weight. The AHUs were located on in the mechanical room that was on the top floor. The elevator would go to the top floor, but they still had a flight of stairs to take everything up to the mechanical room. So not only they had to fit everything in the building, fit everything in the elevator, they also had to take everything up to the AHUs and install everything. The government of Northwest Territories has a component weight limit. So not for the install, but if anything failed in the future, they had a weight limit for any component for any of their personnel that they would have to carry it up the stairs for future maintenance. So they had a weight limit of 75 pounds. And any component had to go through those doors. You see, there were two doors on that air handling unit for return supply fans. Anything had to go through that 24-inch door. They also had a very short window for installing and commissioning. It was quite close to the end of COVID times, and they only had 1 day or 2 days, I think 1 weekend, to install everything and start running everything to the max, so that everybody was coming back to the office. They wanted everything to run after 2 days. And the solution was a Q-PAC kitted fan array. We, because of the weight limit, we had to go with pretty small fans that would fit in that weight limit for the government. So we had to go with a lot of fans, especially on the supply side, that the static was pretty high. On the return fan, we had to go with 12 fans. So very large fan arrays, a lot of fans to be used, just to comply with that weight limit that they had. We actually used our lightest fans on the supply side that were only 44 pounds, so way less than what they actually needed. We gave them 100% redundancy, so this time they are not going to be worried when one of these fans failed. The system is going to keep working and delivering the design CFM, and they will have time to replace that fan. Just because of their remoteness, they got a spare fan for both their supply and return. They actually got spare components for everything, including controls and everything else, just because they didn't want to wait. It's a remote location, so they didn't want to wait for shipping time. And the install and commissioning happened during 1 weekend. So everything was up and running after that 1 weekend that everything was installed. A couple of pictures on the left, that is the return fan, the 12 return fans. And on the right, as you see, it's a portion of the supply fan array. You can notice the wiring isn't done, so it's mid install. So the fans are on the wall, and they're just going to do the wiring between the fans and the quick connect boxes that are on the left. Because of the number of fans that we had to go with on the supply side, we actually had to provide these with 2 control panels. So we went with 2 sections, and each section would be 16 fans, and each 16 fans would have its own power and control connection. So it gave them another layer of redundancy as well, which actually worked pretty well for them. So if anything happened to the controls, it still have some redundancy in that fan array until they had a spare part, so they could replace that in a matter of probably an hour. A couple more pictures. I said there were 2 control panels on the supply side. As you see, those 2 panels side by side in that middle picture show the control panels that are connected to each half of that fan array. Again, on the left side, they are installing that. You see the wires are already in place, so that's pretty close to the end. So the reason why they replaced these fans was not at all energy saving. So they did not even ask at the beginning what the energy savings would be on these fans. But they actually came with a great return on investment for them on this. As you see, I'm just comparing the supply fan here. So I'm just showing the supply fan. The existing supply fan was 150 horsepower. We replaced that with a smaller horsepower on the supply fan for us. So the combined horsepower of our fan array was 132 horsepower. So we went down, which is what we expect when we replace these induction motor fans with our EC motor fan arrays. We expect that reduction in horsepower. This was pretty high static. I think we went up an inch here. So we went up to 8 inches of static on the supply side. So when we go higher static, we get closer to the existing fans. As you see, it's not as low. It's like we reduced 20 horsepower there. Static efficiency, this was a fairly efficient fan. They had the existing fan was 63%. As I said, it was a backward curve SWSI fan wheel, and that went up to 66%, the static efficiency just on the air. But the big difference came from just the motor size. So the current efficiency was below 50% on their system. That went up to about 60%. So a great um, a great increase in the efficiency. So this is, I see a question from Doug. This is a VAV system, but we didn't even look at part load. That's where EC motors become really efficient. But we're actually looking at full load operation, 12 hours. So their return on investment is definitely going to be less than, I think what we got for them was 2.7 years. Although that's going to be way less than that, because they had a VAV, they are going to operate at part load. Definitely, they had a building management system that's going to manage they had outdoor air, so they were going to manage the on-demand ventilation and for cooling and heating as well. So yeah, this was a great return on investment for them, just for a system that they didn't even were asking for it. So I think they got a really good deal on this one. We will hopefully get actual data. This was installed I think in March of last year, so we could get a full year of data and compare it and see how it is pretty soon. So I think this is a good case for us for a case study as well. I'm done with my portion. So Morgan, you want to take it over and see if there are any questions? I don't know if people can actually speak or.
Yeah. Hey, my name is Eddie. I'm the promotions coordinator over at Q-PAC, and I will be the MC fielding the questions. So if anybody has any, we're really happy that you were able to join us today. Feel free to enter those into the chat, and we will get our experts on it for you.
Yeah, and in the meantime, before if anybody has any questions, I just wanted to go back to this. And as Kurt mentioned, we do have tools that when we're dealing with a system that is 30 years old, you don't get a lot of information on the existing fans, but we do have tools to assume, make some assumptions and see how it is, to at least get you some data on return on investment, some data on energy savings. I know there are incentives to go with more efficient systems out there in a lot of the states, and this is a great way for the people to get it.
Question from Doug asking if we can describe the Quick Ship program.
Kurt, do you want to take that, or do you want me to?
Yeah, I can take it. So right now our standard lead time is around 4 weeks. We do have really we go down as low as 48 hour, and they're kind of case by case. We have had the capacity to do 48-hour quick ships over the last couple months, and we should continue to have space in production over the next 4 or 5 months. We're kind of leaving a little bit of room for that. So really just ask your account manager, and they will talk to production and see if we can put in that quick ship. Usually the answer is yes, but we'll let you know same day. Did that answer your question, Doug?
And while Doug is getting back to us on that, Tyler asked, what sort of wiring is required between the external control box and the internal quick connect box? Is it separate for power and controls? The picture you showed looks like it's only one, or shows only one.
Yeah, I can take that one. So it is, you do want to run those separately, 2 lines of conduit. It's an eight conductor control wire, and the power wire, we give you the MCA so your electrician can size that in the field.
I was trying to see if I could find an image of it, but I couldn't. Maybe this one? Yeah, so we could see it, the 2 right there.
Awesome. Well, if there are no more questions, thank you everybody for joining. We will do this again On April the 27th, we're going to go over some application things. So like, it's really easy to see a before and after picture and think, oh yeah, that's obvious. But sometimes whenever you first go into the facility room or the maintenance room, right, you're like, okay, where do I put this? How much room do I have off the coil? Is my ductwork even big enough to handle the air velocity? Sometimes there's some changing your air handler from being negatively pressured to positively pressured. So we're going to talk about some of those things next time in about a month. So thanks, everybody.
Thank you all.
Thank
Bye,
you.
y'all.